Today we're going to talk about is, equal, and IDs. Let's take x and assign it the value 1, 2, 3. What's in x? 1, 2, 3. What's the ID of x? That's its location in memory. I'm going to take y. I'm going to assign it the value 1, 2, 3. Let's ask ourselves the big question. X equals y? True. X is y? Do they point to the same object in memory? True, they do. Let's take a look at that. X and y both have the value 1, 2, 3 in it. But where are they in memory? Do they occupy the same space in memory? Let's see the ID of x and the ID of y. And same ID numbers. They occupy the same space in memory. So what Python did was it took an area of memory. It has 1, 2, 3 in it. And x references this area of memory. When I assigned 1, 2, 3 to y, Python caused y to reference the same area of memory. Time saver. Big time saver. What happens if I change the value in y? Let's find out. Y equals 2, 3. Let's ask ourselves the big question now. Does x equal y? False. X is y? False. They have different locations now in memory, I suspect. Let's take a look and find out. Yes, these are different memory locations now. They have been switched 1984, 3584. So y got switched to this area of memory. System put a 2, 3 in there and erased y's referencing of that area, and now is causing y to reference this area of memory. Does Python do the same thing with strings? Let's find out. A equals George. B equals George. A equals B. True. A is B. Let's find out if they're referencing the same area of memory. True, they are. So the ID then of A and the ID of B should be the same. And they are. Does this always hold true? Answer, no. Let's take a look at lists. X equals, let's use the same numbers, 1, 2, 3. Y equals 1, 2, 3. X equals y? True. X is y? False. Ooh la la, what just happened? Let's find out. What is the ID of x? And what is the ID of y? Ooh, these guys are separate. What happened? Well, Python put the list 1, 2, 3 in this area of memory and caused x to reference that area, and then did the same thing with y. But it caused it to reference another area of memory that has the same data in it, same data as this guy. But these are separate areas of memory. As you can see here, they have different IDs. So here x and y are referencing two distinct areas in memory that just happen to contain the same value. X is not y. And if I key that in, x is not y, I should get a confirmation from the system saying true. And I do. Why? Because they have different ID numbers, different areas in memory. That's what is checking for. ID equality. Can I change that? Yes, I can. X is y? False. But what if I key in x equals y? Now what did I just do? Now I took x and I made it reference the same location as y is referencing, like so. But you say to me, what will happen to this poor guy over here? Going Garbage collection, garbage collection will come and take him away, like that. So, X is Y now? Yes, they have the same ID. ID of X and the ID of Y are same. Of course then, X equals Y. True. Because now they point to the same object. Does Python behave that way with floats? Let's find out. A equals 5.222. B equals 5.222. A equal B? True. But A is B? False. Why? Because with floats, what Python did was it created an object in memory, put 5.22 in there, like so. Then it created another object in memory, put a 5.22 in there. It caused X to reference that first 5.22, and it caused Y to reference the other 5.22. These are separate objects in memory. Python treats floats differently. Wow. Can we be certain of that? Let's find out. What is the ID of A, comma, and what is the ID of B? They're separate objects. They have different IDs. Can we change that? I'm going to take A, make it equal to B. Now, what just happened? A equal B? Of course they do. But A is B. Are these guys the same object now? True, they are. What just happened? I used the wrong variable. Okie dokie. This was A and B. And what we just did was we took A and assigned it B's location. So now A is referencing this object in memory. And garbage collection will come along and take him away. So, how did we do that? A equals B. Now are they equal? Yes, the value is the same. Do they have the same location in memory? Yes, they do. A is B. B's location is now A's location. They are referencing one and the same object. And let's be absolutely certain. I key in ID A, comma ID B, and we get the same location. Former location of B is now being referenced by A. What do you know? That is amazing. Well, that's it for now. Thanks so much for listening. If you like this video, please click on the like button below. I'd appreciate that. And I hope to see you in the next video. Bye-bye now.